Hel- Hello, folks. So, basically, this is a detailed explanation, one short video for this chapter Introduction to Problem Solving, Class 11 Computer Science, and these things I'll be discussing here, as you can see in the left side of this map, right? You can see. So, yeah, let's start with this chapter. Previously, we discussed the introduction video, what we'll be covering, so that was just a glance, and this is a detailed video of this unit 2 introduction to computational thinking and programming, introduction to problem solving. So yeah, let's start. Introduction. Yes, let's reduce the size a bit and start. So we use computers every day to book your train tickets, air tickets, shop online, pay the bills, and forecast the weather. So all these are made possible because computers are programmed to solve problems. To solve problems, because computers don't have their memory, they cannot think on their own. Even AI is like, it is being searching from somewhere, right? It has some database, right? It has some records, or it is searching from the web or whatever, written a post. So they need some precise step-by-step instruction written by a programmer, normal code, okay? And the quality of the solution depends entirely on how well the programmer understands and defines the problem. So basically, as it written here, the success of a computer program depends on how correctly and precisely we actually define the problem and design an algorithm to solve it. In the few frameworks or other thing, defining the problem in the ACT principle, we studied this in the intro video. We saw that what is that, and implement the solution in a given programming language. In this chapter, we're discussing all the fundamental skills needed to approach any computation problem systematically, and from understanding the problem, writing and testing the code. So what is a problem? In computer science, a problem is a task or challenge that requires a well-defined solution. Well-defined solution. And every problem has three components: input, some processing, and some outputting. Input is the data that is being given to your computer. Processing is the logic operations that is being performed on the data or the calculation. Output is the result produced at the end to the user. The real life example of problem we can take, like train ticket booking. What is the input there? Can we just say we have the source from where we are going and to where we'll be going, that is the destination and the date we'll be going, right? And process, check the availability and which train, all these things. Now output, the booking confirmation ticket will be getting, like that in the online e-commerce platform shopping. What is the product choice and the money is the payment is the input. Process is verifying the payment, doing the update, the stock gets decrement by one or something, and output at the order place, the invoice will be getting and delivered to our home, right? Like that in net banking, what is the input? The account details, the amount. Process is the debit or credit. Debit means we're actually uh, transacting out the money, and credit means going, the money is going in, right? Something like that, okay. The output is like transaction information at the end. In weather forecast, input is what? Sensor readings. Process is a model calculation. Output is a weather prediction. So these are certain examples of this. So when defined, so these are real life example of problem. So then understanding what is problem solving actually. The problem solving is complete process of identifying a problem, developing an algorithm for it, and finally implementing the algorithm as a computer program. Let's say from something like cooking a new dish, let's understand from perspective of cook. So if you're a cook, we read the recipe, what is there, to understand the problem or what we have to make actually, and not the food. The recipe is actually the logic here, the steps, and actually what you cook, that's the coding part. And then you test it, testing part. If something is wrong, again we like how to debug it or fix it. We're adding some extra salt or some extra sugar or water or whatever. These are the things in real life we do in the analogy of a kitchen. So you have to remember this: identify the problem statement, design the solution logic, code it, test it, and debug it. And this is an iterative cycle, it doesn't stop, it keeps on happening, right? Then these are the five steps for problem solving. So yeah, CBSE sometimes it may be asked is, I mean, in school exams even, what is the steps for problem solving? Always list the 5 steps. Analyze the problem, yeah, for you can say that's understanding the problem statement, right? Then developing an algorithm and logic to solve it. Then developing a pseudocode or something, then converting into a language. Let's say we're using Python for this course, and then testing upon it, testing the given sample uh, values and what is the resulting output. That's a dry run or something, anything. It may be automated testing also. Then debugging, and if it's wrong, then again fix it. Then out iterate the whole loop and the process, right? Then is a and first step is analyzing the problem. What is analyzing the problem? Clearly understanding what is the problem is asking, what is the inputs, what is the processing that is required, and what is the expected output. That is the most critical step. If you don't understand the problem well, we may build a program that doesn't solve it correctly, or some edge cases are there that still remain unsolved, something like that, right? Like think of it as a doctor examining a patient before prescribing medicine. Without proper diagnosis, the treatment will definitely fail, right? So what do you do is in the during the analysis phase, actually what we do, we ask that what is the input, or what data does the program need to accept from the user, what processing needs to be done, or operations on that given data needs to be performed, and what is the output, and at the end what the result should produce to the user. Let's say there's a area of rectangle you have to do. That's the problem statement. To figure out the area of rectangle, what is the input? Length of the rectangle, the certain breadth of the rectangle. These two input values we need. And processing, there's a formula for it. How to do multiply length into breadth, then store it in a variable named area. Then print the area, like area of rectangle, to the end user. So that is a always analyze the first. What is a problem statement deeply? Then develop an algorithm to solve it in the step 2. So, huh, what is an algorithm basically? Algorithm is basically a finite ordered sequence of well-defined instructions that, when followed correctly, solves a given problem and produces a desired output in a finite amount of time, just like a recipe. A recipe tells you exactly what ingredients to use and what time it had to like do the cooking and in what order you have to do, especially don't mess up the things, right? And just like the algorithm tells the computer exactly what to do in a step-by-step sequential format. What is the characteristics of the good algorithm? The Puffio framework we studied, right? In the intro video, so we discuss in the framework. The characteristics of a good algorithm we discuss in the Puffio framework. This is a mnemonic. First is precision and preciseness. Other is a uniqueness, then finiteness, input, output, and last it should be effective also. So we're gonna papio, we can also write it like this. So let's discuss what is exactly this. First, what is precision? Precision means every step must be clearly and unambiguously defined. Let's say divide a by 2, not k, not cut a roughly a in half. That is not the same thing, right? Uniqueness means each step's result depends only on its input and previous steps. No steps should give two different results, alternating results for the same input process. Finiteness means algorithm must terminate after a finite number of steps. It should not be just endlessly going infinitely. An infinite loop is not a valid algorithm. It should stop somewhere, some base case should be there. It should stop some should be there, right? Exiting somewhere. The input, the algorithm must accept zero or more inputs. Like there's a number, there's a data structure like a list, or no input at all can also be there. Everything is done by the system itself. It can be also a case. In output, the algorithm must produce at least one result. Yeah, output, write to a certain file or display a result, anything. And effectiveness means every step must be implemented in a simple, practical, executable manner. The steps should be like this, no hack steps. I solve world hunger, but how to do it, right? So yeah, so this steps you can remember Puffio framework, or there's a memory trick Puffio E. Okay, please use mnemonics is please use 5 instructions only every day. You can remember this. Sometimes it might be a exam. This Puffio E principle you can remember like this. Please use 5 instruction only every day. Okay, then why do we need an algorithm? Before writing the actual code in a certain coding language or programming language, we need a roadmap. Just like architect or system architect plan the components or the blueprints before constructing a building or a house, anything. The algorithm increases reliability. Means correct algorithm gives the correct output, you can rely upon it. Accuracy, logical errors, fallacies, all these edge cases should not be left, it should be covered and solved. Saves time. Fixing an algorithm easier than fixing hundreds of lines of code afterwards. Aids communication with others, can understand, verify the login. That's why documentation is important, to just document things, right? So if we are here, we build a certain program or write a certain code, the other person should be able to understand. If we are not here, at that person afterwards or something, right? But the program will continue, but the people will not be there in that particular team or something. Okay, then for a given problem, more than one algorithm is also possible. You have to choose what is the most optimized thing. So we can compare later. In higher studies, we have time complexity and space complexity. Time complexity means what is the processing time it takes, and space complexity, memory being used. Considering both the things, you have to optimize the solution. Sometimes a algorithm might be very less time taking, but it may very high memory intensive. A space complexity is very high, that will be not the good case, right? And sometimes it may be taking less space but very much time, high amount of time, that is also not feasible. So on that basis we have to see what is the most optimized and middleman kind of solution you have to figure out in those steps. So we're learning those later. Okay, so these are some of the algorithms that are written in the CBSE NCRT works. I mean, textbooks, it's there. There's an algorithm to find a number whether it is even or not. So these are basically the pseudocode it's written in English, like logic and so. So these are pseudocode. It's the star step we can design. You take an let's say even object. Take an integer number, let's say a as the input. If you take the a as the input here and divide a by 2, if it is equal to 0, this modulo operator later will be saying in the subsequent chapters. If it is given remainder as 0, then it is a even number. If it is 1, then it is a odd number, right? So these are if then statements have been there, if else or whatever. Then you start it, then you stop it. Here the algorithm is stopped, like that. Then some other question like this: find the square of a number. In the square of a number, what will do? You take a number, let's say a, and compute the square of the number. The square, let's say, we store in a value of like square of a number, that is a asterisk a, with a multiplied by itself. So it is a square, and print this. Let's say you have 5. The 5 into 5 you did as 25. The 5 square is 25. We know that, right? To like that. Then check when number is prime or not. This is one of the important question even later also. How to check if a number is prime? But prime, okay, take an integer in number a, divisor at 2. If it is divisible by 2, set the flag value as 2. Means now you have to consider it as every number is prime. Then from divisor to a minus 1, divide a by divisor, store remainder r. If r is 0, then set flag equal false. But what is the prime number definition? It's not divided by any other number beyond itself and 1. If it is getting divided, flag value, certain flag value, later higher studies will be saying this, what is flag value, flag equal to true or flag equal to false, will be having this value changing in the program later. And then if it is false, then it is not prime, and it is else a is prime, like that. Some other thing, this is later, don't rely upon it a lot. Okay, let's go to the next part, the coding part. What is the coding? It is a process of conversing this pseudocode or flowchart, anything that were flowchart. How to do it will be seen later. How the representation will be done. That is a pseudocode previously we discussed. In coding, the process of converting a finalized algorithm into a certain program written in a high-level language, whether it's Python, C, C++, Java, JavaScript, anything. The computer can understand and execute it. Once the algorithm is ready, a programmer translates the actual code, the syntax, following the syntax and grammatical rules of that programming language. And this code is known as a source code. So you already know what is a high level language, what is a low level language. No need to say. Okay. A program written in a high level language is called a source code. It must be translated into a program using compiler or interpreter. What is the difference we know before it can be executed by the computer. That becomes an object code later, right? Okay, you may know what is a compiler interpreter difference. Compiler translates the program at once in one go. Interpreter does line by line. Python is an interpreter language. It does line by line, right? uh, okay, then is a testing process. Testing and debugging, there's a difference, so let's focus on this, a difference between that. And okay, testing is a process of running a program with various sample inputs to check whether it produces a correct and expected output or not. And the main objective of testing is to find actually errors, right? We have to find errors just like a QA testing or quality analyst tester, QA tester in the industry. So what does a well-tested program do? Meet all the requirements of the user. No, all means solve the edge cases also as well. Responds within the expected time. Generates correct output for all possible inputs. All test cases must be passed, at least the sample ones. Doesn't crash due to some syntactical errors. Types of testing, later in higher studies you have this testing types you have like, and frameworks like unit testing is we test the individual modules or function of the program separately. Then integration testing, when we combine different functions, module, methods or blocks of code to check whether they work correctly or not. Then the system testing, or this is known as the end-to-end testing, end-to-end testing. So it is E2E, or the end-to-end testing, complete testing the whole system, integrated system against the requirement. The system testing. Acceptance testing means it is by checking whether the software meets all the business and user requirements or not. Generally, these are the three main types: unit testing, integration testing, system, or the end-to-end testing we have. Then in, okay, that is testing process. But what is debugging then? Debugging is a process of locating, identifying, fixing the errors or bugs in a program found during the testing phase. What is the key difference actually? Testing is to find errors, debug is to fix errors. In actually like one line, one uh, phrase form is that. Okay, types of errors. Later we'll be seeing this chapter. There's a in class 2 there's a escapes and handling chapter. But here we should know at least for the basic syntax error is there, right? That is grammatical rules of the language are not following. They're missing colon in Python, literal missing, where we are encountered. Logical error means logic is wrong, plus system multiplication some methods, logical error. Runtime error, runtime error, may it is program compiled successfully but crashes during running, like division by zero. Compilation happening, but division by zero is undefined, right? So it is a runtime error like that. So sometimes the question may be asked, 2 or 3 marks may be differentiated between testing or debug, even one line. So just use a definition or write table something, and just bit descriptive, just write it whenever it is asked. Okay, then we go for the representation of algorithms. These all algorithms that we developed, how we can represent them in the format, either in a flowchart mind map format or just like textual pseudocode format, English like logic, right? Both method should show the solution without including the actual programming language details, without going into that abstraction and complexity, and should clearly reveal the flow of control during execution, the step by step ordering clearly documented back there. So going further, let's say in a flowchart way. Okay, I mean representation overview we're going here now. What is a flowchart? It's a graphical pictorial representation of algorithm, just like a mind map or revision or of that. And chapter summary, you see that it uses some standard geometric shapes connected by arrows to show the step-by-step flow of a solution. And each shape has a specific type of step. One shape is particular for the start, or some for decision making, some for process logic. Arrows shows the flow lines will show in which direction they are going. Flowchart has always one start and one stop. So seeing this flowchart symbols here and what is the purpose, what they use for. This oval here terminator, it is used to begin a program or used to end a program or the flowchart. Rectangle is for processing, the processing step, calculation, logic, mathematical part, anything, assignment to a variable, all this. Parallelogram, if else, sorry, input या output operations. Input output is parallelogram. Diamond is a if else yes no true false or the decision making conditional part. And arrows flow in the direction of the flow connection between the steps. So remember these things are very important. We'll be using the flowchart to decode a certain problem statement. Here we'll be seeing like this. Even an odd number. Previously we saw that even an odd number, like here we saw in a which format, the pseudocode format. These are pseudocode formats. But now we'll be seeing this how to do those things in a flowchart like format. Right? So how to do those things in a flowchart like format. Now, so let's say there's a start and there's an input button. Input number we're taking as A, and if uh, the start is with a oval shape, input is with a parallelogram, and diamond shape is a conditional one. A modulo 2 equal 0. If the remainder is 0, flow line 1 to print even, and then print odd. So all these things are in the rectangle for the printing purposes because these are certain logic, right? So these are rectangle, and the end they are again terminating at the stop. That is the oval terminator is being right. So you can understand this starts with the oval for the starting part, end with the oval for the ending part, and for taking a input we are using a parallelogram, right? To make a decision we are if else statement we are using a diamond shape, and to print something we are using the print function in Python also we'll be using it. So we are using rectangles for the logic part, and at the end we are using a oval to end it. So these specific steps and arrows and flow lines are between to connect to so the direction how the program is flowing up and down or wherever. Then is a square of a number. So how to take a square of a number? Same. The oval is there to take a means to start. And input num will be doing, let's say in a parallelogram. Logic the square num asterisk num into num you are doing storing a variable square. That is in the logic part. So it's in a rectangle. Then again print the square. The printing the square. Uh, this might be in the square one or maybe in the parallelogram one. Because output we are giving, you can have a parallelogram also as well, because sometimes a return statement might be the lateral way encountered. So you can both can be used for this, and the stop can be used at the later others ending. So yeah, so that is the wrong symbols don't do it, right? I label everything correctly as it is happening by writing the flowcharts. Then is a pseudocode. So what is a pseudocode? Pseudocode is an informal, readable, English-like description of a algorithm. It is not an actual program and cannot be actually executed by a computer. It is used by programmers to plan their logic before writing the real code. The pseudo means not real, so it literally means literal meaning not real code. And the key features part of the pseudocode, not language specific, it is language independent. It can be converted later to any programming language like Python, C, C++, Java, JavaScript, anything. It cannot be executed by the computer, no specific standard is there. So different textbooks may use different keywords. So it's not universal standard, but the shapes and the flowchart has some particular shapes for this thing, right? So that has a standard. Here not a standard. It is common to human language, natural English, so it is easier to understand. The common keywords that we use in the CBSE NCERT textbooks is written. Input is uppercase input is there to take accept data from the user. Let's input a number, right? And print your output to display result to a user like print even, compute your set, perform calculation or assign some value here. Compute r equal to a modulo 2. If it is 0, then store it somewhere. If, else, and if, these are for decision making. Then also while, repeat. So these are looping. While loop will be standing. So while count less than 5, keep the loop going on. Increment, decrement. Increment means increase by value by 1. Decrement means decrease value by 1. Start here, stop. Mark the starting and the ending of a program. The advantages of this pseudocode are easy to convert, easy to read, prevents some mistakes. जैसे कि there's a pseudocode example. So if a number is even or odd, input number A, compute remainder equal to A modulo 2. If remainder equal to 0, then print even, else print odd. So as you can understand from this, right? Sum of two numbers, input num1, input num2, compute result equal to num1 plus num2, then print result. Then five average of five numbers using a loop. The how, you have to take a counter variable here, set count equal to 0, and to find the average, you need the sum equal to 0, assign it. While count less than 5 means while the count is less than 5, keep the loop going on, repeat the steps 3 to 5 here. Input a number to num, sum equal to sum plus num. If it's sum, it is now 0. I will take in this number, let's say 1. So I'll be taking 1, and again I'll be taking a number, second number, let's say 2. So now it is becoming sum plus that number equal to, now sum becomes 3. So it is actually going on compounding, it will be going. So these are known as compound assignment operators also, or augmented operators, later we see. And this step later in programming in Python or other languages, right? Sum plus equal to num, right? Then count equal to count plus 1, later count plus equal to 1, count will be incrementing by 1, right? Then compute average. How to do the average? Sum divided by number of entities, that is like 5, and then print the average. In programming we will discuss in that, this is just a layman's language. Categorize child as a child, categorize a person age as a child, teenager, or adult. Input age. If age less than 13, then print child. Else if age less than 20, then print teenager, or else print adult ended. Any condition. Here it is a general condition like 20, or you can take here, let's say 18 also. Our standard is 18 in our country, so we'll be taking it. Okay, in this statement instead of 20. So what is the key difference then between them? Flowchart, pseudocode, advantages, disadvantages. There may be a major question to compare both these things. Use a table format at least to have some 3-4 comparison points. In flowchart, there's a pictorial and graphical representation you get, and pseudocode you get a textual representation. The flowchart uses standardized geometric symbols. Pseudocode use English like keywords. A flowchart is very easy to visualize logic, and at the end you can see the big picture what is actually happening. Pseudocode is easy to read and understand than a programming language, even than a high level programming language, even like, okay, it is language independent and platform independent also. In flowchart, it is difficult to modify once drawn, but pseudocode it is easy to erase and then write a new line there. But from flowchart, you have to redraw the shapes. Like if we alter the shape in between that other, and also in altering something shape, and it's time consuming to draw the thing, but it's faster to write the thing. Flowchart is better for simple problems, but complex actual code, uh, to convert into code is to write actually pseudocode. Right, better for complex problems. Then is decomposition part. What is decomposition? Decomposition is a process of breaking down a complex large problem into smaller manageable sub-problems that are easier to understand, develop, and solve independently. The spirit of decomposition in divide and conquer, as mathematician Howard Ruffer said, decomposes complex problems into smaller ones, gets one thing straight in the simple problems, put these analyses together logical do, and then together then you can find the solution at end. So why is the decomposition? Easier problem solving, smaller problems feel less overwhelming. Parallel development means different teams can work on different sub problems simultaneously. So actually, have a time, it is time saving, right? That everybody can working on separate things, and together at the end, time is being saved. and the thing is being happening parallelly, right? Parallel development. Domain expertise means each sub problem can be assigned to particular experts in that particular domain who have expertise. Easier testing, unit testing can be done here. Each sub problem can be tested independently, then fixed and debug anything. Then better maintenance, fixing one part doesn't break the rest of the part. We can see how the connections actually work. So we can fix one part, alter one part, not everything in one thing. So break down the things. The real life example here for railway reservation system. You can see the complex tasks of building a railway reservation system is broken into smaller subsystem like that of a school management system, hospital management system, banking application management system, library management system, anything like that. The railway reservation system, let's say, we can break down as a train information. What is the schedule of the train? What is the seats and what are the classes or coaches? Okay, AC, non-AC, other things here. Reservation system, booking, cancellation, billing service or the payments or the refunds, food service, pantry car orders, staff and security, staff management, other digital infrastructure, traffic control, engine. So each system is built and tested independently, then integrated together. Right. The other example of decomposition is a school management system. In school management system, you have student records, attendance, examination fee, teachers, each has separate salaries, so each has a separate module, right? In the online e-commerce platform, product catalog, shopping cart, payment system, delivery tracking, they're all built separately, all these things, right? Entities. Weather forecasting and data collection, model processing, prediction output, three distinct sub-problems we're seeing. After all the sub-problems are actually being solved individually, they must be integrated together and tested together. That is an end-to-end system tested to produce a complete solution, right? Then flow of control is there. Flow of control means what describes the order in which an algorithm is being executed. Three types of flow of control. One is sequential, other is selectional, other is a repetition or the iteration. Repetition or the iteration, this one is iteration or the looping part, it is also iteration. It is O by the way, but it is also known as a loop. Sequence means one after the other or line by line repetition in the same order. Selectional, mainly decision trees or sorry in diamond shape, if else then if else shape, all these things. Repetition means again it will just iterate of the same process just like a loop, for loop, while loop. Later we'll be seeing that in the subsequent chapters. If else structure, if then steps when a condition is true, this else steps when this condition is false, then and if. In while if such a while condition is true, do that steps to repeat increment the counter, and while this statement is not true, like that, or till this condition is not getting false, right? So there, questions asks you to write pseudocode or flowchart for a problem almost use always involves at least two of the three flow types, maybe selectional and conditional, means sorry, sequential and selectional probably, and sometimes iterative or the repetition flow. So as we are coming into this chapter, let's discuss what are the common mistakes that the students make. Skipping analysis, we have to understand the problem statement, what is the given input, or what we have to take the input from the user and do the processing part, then the output part. Sometimes if you miss the thing, incorrect or incomplete programs at the end will be dealing with. Then confusing testing and debugging. Testing finds the errors, debugs fixes the errors. These are separate steps. Wrong flowchart symbols. Rectangle for input output. Don't use rectangle is for logic purpose. Input output is a parallelogram. Diamond for a if else statement, decision making. Start and stop in a flowchart, don't miss it. The terminator, like just like you write in a pseudocode, you have the oval shapes, right? And confusing pseudocode with Python code, don't use those language syntax here. Those keywords you use it like input, prints, compute, and then start, stop also. Incomplete algorithm, forgetting to start and stop, numbering the steps, okay, not covering the else condition, edge cases. The good algorithm must handle all the cases effectively. So these are okay. So basically these are the revision things. You can see what you actually covered. So you can see and take screenshots of these things. You'll be getting the notes, by the way. That's not a problem. The Google Drive link will be shared in the description or also in the comments. Probably in the description. So yeah, you can see this and see the summary of this table. Some important questions. These things can be take a screenshot of this. And yeah, that's all. And next chapter will be coming introduction to this Python programming, chapter 5, class 11 computer science. So stay out here for that intro video. So yeah, that's all. Hope you liked the video. If you like this, subscribe to this channel and all. Yeah, that's all. Thank you, folks. Bye bye.